Okay, here's the chapter 2 sample test video. So, is f of x a function? So, if I made a mapping diagram, that'd be one way to look at this. And we have 7, 4, 6, 2, and 5 in the domain, going to 4, 3, 3 I already have, 5 and -1, and the mapping diagram says 7 to 4, 4 to 3, 6 goes to 3, that's not two timing, they're different people going after the same person here, and 2 going to 5, that's okay, and 5 going to -1. No two timing, no domain going for more than one, a match to more than one range element. No domain element mapped to different range at least two different, more than different, no, different range elements. So, function. Okay. 2, kind of hard to see, but if the following is not a function, give evidence that demonstrates why. If I do a vertical line anywhere between 1, 2, 3 and 6, it looks like here, I hit it in two places. Not passing vertical line test. For domain somewhere between 3 and 6, looks like. And it might include 3 and 6 because there's no dots, you can't really tell. So it could be closed brackets on that if I wanted. Find the domain of this. The only thing that go wrong here, remember, the problems come from square roots or even roots of negatives or division by 0. No division in this, so the only problem we have is can't have negative in there. So inside the 2 minus 4x can't be less than 0. It has to be greater than or equal to 0. If I subtract 2 from both sides, I get -4x greater than or equal to -2, and if I divide by -4, I get x dividing by a negative, so that's going to flip the sign, and -2 divided by -4 is +1/2. So the domain would be from -infinity up to 1/2, including 1/2. That's in interval notation. In set notation, it would be the set whose elements are numbers such that the numbers are less than or equal to 1/2 in set. I could write also all reals less than or equal to 1/2. F of x in problem number 1. What's the domain? Well, I said that when I made this, but let's put it in set notation. We have 2, 4, 5, 6, and 7. Interval notation would be a pain in the rear. It would be from 2 to 2, union 4 to 4, union 5 to 5, union 6 to 6, union 7 to 7. I can't say 4 to 7 because it doesn't have the numbers in between. So set notation is the easiest. C. Define the domain of this. Well, I don't have any square roots, but I do have division, and I cannot divide by 0. So x squared minus 4 cannot equal 0. If I add 4 to both sides, that means x squared cannot equal 4, which means x cannot equal 2 plus or minus 2. So I could say all reals except 2 and negative 2. I could say from negative infinity up to negative 2, not including it. Union from negative 2, not including it, up to positive 2, not including it. Union from positive 2 to infinity. All right. 4. The range. The lowest value I have is the negative 1.8. And it does include it. Up to, I have to be careful there's no breaks here. There is a value for 0, so that one's okay. There is a value for 1 over here, so that's okay. So it goes all the way up to a height of, I got y values for everything, all the way up to 2, not including the 2. Find the x-intercepts. That's an open hole, so that's not an x-intercept. That is not an open hole, so we have an x-intercept of negative 1, 0. And we have one over here at about 2.3 or 4, approximately 2.30. And no more x-intercepts. Are there any y-intercepts? We have one at 0, 1.5. M of 2. If I go to 2, the y value, m of 2, is about 1. So the y value at 2 is 1. It's not a point. It's just saying, what's the y value at 2? 1. What's the y value at negative 2? Looks like it's about negative 1. If you read that graph a little bit different than that and come up with a slightly different estimate, that's okay. Find the local maximums. Okay, so that's high spots that would water would run off of, not through. So it would run off of this, but not both ways. It would run through there, so there are none. Local minimums. Is there any place where water would puddle? It looks like it's here, and the minimum is the y value, and that is negative 1. And we can say at x equal negative 2. Absolute maximum, very highest place. Well, it keeps going and going and going and getting closer and closer to, but we never can determine what it is, so no, none. Absolute minimum, very lowest place, is over here. It's negative 1.8, happens at x equal 3. That's page 1.